Welcome back. James Duffy here, and it's time to begin construction of our 1/48 scale Soyuz booster from Estes. We've taken a look at the parts in our previous episode, as well as outline a basic build plan. To recap, this project is going to use traditional plastic model building skills, much more so than standard model rocketry construction. We're only going to highlight the steps that are unique to this model or might be alien to traditional rocket modelers, as well as a few of the most critical operations. I'm making an assumption here that anyone watching this video already has some basic building and finishing skills. With those expectations set, our first step is going to be to assemble the motor mount and central core, which starts out much like we would on a standard model rocket kit. We've already primed and sanded the paper BT-60 tube for the central core of our Soyuz. Only the lower 9 5/8 inches of this part was primed, as everything north of that will be hidden within a blow-molded component. We'll start by marking the tube for the 4 forward mounting pads for the strap-on boosters. Cut out the marking guide. Yours may look a little bit different than this, but it'll work just the same, and wrap it around the lower core tube. Tape the ends together with a bit of clear tape and align it with the aft end of the tube. I like to lock that in place with an extra piece of tape. I'll use an awl to mark the 4 mounting pad locations and then use the side of a ruler to extend the cable raceway lines along with the reference line. Next, a tiny drill bit is used to enlarge the mounting pad locations. One of the mounting pads can be trimmed from the sprue to test the fit. I'm using the tip of a number 11 blade to slightly enlarge the hole to refine the fit. Grab the 2 centering rings designed to center the motor mount tube within the BT-60 central core tube, and note that one of them has a hole. This hole is for routing the Kevlar shock cord anchor, and we'll install that in the forward position. Mark a location 3 1/8 inches, that's about 80 millimeters, from one end of the 29 millimeter motor mount tube. This is the ring that will be installed in the aft position. Glue both of the rings in place with epoxy, placing the ring with the hole flush with the forward end of the mount. Okay, the epoxy on our motor mount has cured. So now we'll install this recovery system anchor. We'll take the Kevlar cord, insert it through the hole in the top ring, take it around the mount, and then tie a simple knot to hold it in place. Now that that's in place, I'm going to take a couple of drops of thin CA glue and lock that knot into place. And our motor mount is ready for installation. Let's turn our attention next to the plastic parts at the aft end of the central core. We're going to cement this central ring into one of the 2 halves of this aft structure. I've got some thin cement here. I like to use a paintbrush. I've got an old paintbrush. I've literally used this for more than 20 years for this very task. I don't use it for paint at all. And I'm relying on capillary action to draw the adhesive into the seam. I'm going to hold that there for a few seconds, probably 30 seconds. I'm going to flip the part around and I'm going to do the same thing on these seams at the front end. Again, capillary action will draw the adhesive into the joint. The way this adhesive works, what it does is react with the plastic and melt it slightly. So in a sense, it's welding the two plastic parts together. Okay, let's put the other piece in place. Again, we're going to let capillary action do most of the work. I'll work in short sections. Hold that together. I'll do the next section. Okay, let's do the other side. Same drill, capillary action will draw the adhesive into the seam. Working in short sections. There's our first section. Okay, and that assembly is complete. I'll let this sit for about half an hour, and then I'll lightly polish these seams with a sanding stick. I have a pair of sanding sticks here, one medium, one fine. You can get these at any hobby shop, or if you're really smart, you'll stop by a beauty supply store in your hometown and pick up an assortment for a fraction of the cost they sell the ones at the hobby shop for. This is a very clean seam on this part. Still, we're going to polish it just a bit with the medium stick. And then we're going to polish away any scratches with the fine stick. Now this probably isn't even necessary, as these joints are eventually going to be hidden under the strap-on boosters. We're going to go ahead and do them anyway, though. There's a concept in scale modeling that I like to call because God can see. For instance, there are guys who will make sure that every seam on a motor mount that gets hidden inside a body tube is perfect. Now, why do you do that? Well, everything you do is an opportunity to further improve your skills. I think this is a great example of that. Okay, we'll stop there. Now we have an opportunity to test fit our motor mount, our core tube, and this aft insert. I'm going to do this without glue first. First thing I'm going to do is just set the motor mount in the aft end of the tube. Just barely let it insert into the tube. I'll then put the aft section in, and it will push the motor mount forward into place. I'm now going to rotate the aft insert to line up one of our seams with this reference line we placed on here that runs through one of these mounting holes for the forward strap-on pads. That's the accurate, appropriate positioning for everything. It's pretty simple to do, but every simple thing to do is an opportunity to get something wrong. So we're going to take it apart. I'm going to mix up some epoxy, and we're going to do it for real. I have some 5-minute epoxy here that I've mixed up with a Q-tip. Now I'm going to use the Q-tip to place a line of epoxy up inside the tube. I'm going to put the motor mount in just so that it's barely in. And then I'm going to put some additional epoxy very carefully in the gap. Now, why am I doing that? Because as we move that motor mount forward, it's going to scrape all of that epoxy forward. And we want some on our motor mount. Okay, it's in place. Now I'm going to find a seam on this aft section and line it up with this reference line. Again, the reference line goes through the mounting points for the strap-on boosters. Now our next fun little task will be to remove the end caps from these blow-molded components. To do that, we are going to use a razor saw. Here's an assortment of razor saws that I have laying around. There's the classic X-Acto razor saw. This is from a company called Zona. And this is a Tamiya razor saw. Predictably, I have the Tamiya product. Any one of these will do this job well. The important thing is you're going to want the finest tooth blade you can get. Now, just because I like Tamiya products so much, I'm going to go with the Tamiya. Now, because this is not my first rodeo, I will share that the most important thing you can do is improve the visibility of the cut lines. I've got magnification on. This is a fine point Sharpie, and I'm going to highlight the seam where I want my cut to be. Okay, that line will do the job. The key here is to work slowly and rotate frequently. Let's get started. I'll put the saw on the mark. Note how I'm rolling the part, rotating it. Let the saw do the work. Could you do this with an X-Acto blade? Yeah, sure. Just make sure you've got the emergency room on speed dial. Just checking here to see how deep this cut has gone. We are making progress. Slowly, but we're making progress. Okay, as the blade starts to cut through, you'll want to rotate it right away. Let's work the other side. And our first cap is off. A very clean cut. We'll do the other end now. There we go, beautiful. Okay, our end caps are off. The next thing we're going to do is use a bar sander and polish the ends. And as we do this, we're going to rotate the part. We don't want to sand in any one spot for more than absolutely necessary. It's going to sound horrible. There's no way around that. Your family will hate you. Let's do the other end. Remember to rotate the part. Good rule of thumb here is when most of your guide mark is gone, you're probably close to done. Now I'm going to take a medium sanding stick and just lightly polish the burr off the end. Okay, we're almost done here, but not quite. The next thing we need to do is sand this lip right here, the inside of the lower half. This is the upper half, this is the lower half. The lower joint needs to be sanded down so that it slides cleanly over the BT-60. Here's our central core. Clearly it doesn't fit yet. So we've got a great deal of sanding to do here. Now I have some 320 grit sandpaper here. I'm going to roll that into a loose tube. And we are just going to polish the inside of this opening until it fits over our BT-60. This may take a while. Something you should be aware of is that the wall thickness of a blow molded part is not always uniform. So check it by eye frequently. You can actually feel the low spots and the high spots on the inside of the tube. Just be aware of that. You don't want to sand through the tube and still have it too fat in some other location. This is going to take a while. Go put some music on, put a podcast on, put something stupid on the TV, and just be patient. See you in a little bit. Okay, we've successfully sanded out this part, and I want to share with you the tool that finally did the trick for me. This is a prototype of a forthcoming tool from Estes. It's a conical sanding tool, primarily intended for centering rings. Now, I used this to scrape out the interior of this wall, and it worked very well. It took about 45 minutes, but it worked well. Now, what do you do about the fact that this tool isn't available yet? Just get a piece of fat dowel, like a curtain rod stock. Cut about 6 or 8 inches of it, about this size, this diameter here, 1 inch to 1 1/4 inches, and tape some sandpaper onto the outside of it. You can do the same thing and accomplish the goal. This does fit on here. It is a perfect fit. And in our next step, we'll get that centering ring installed up here. We have 3 elements here we need to bring together: the central core tube, the upper blow mold section for the central core, and a centering ring for the forward end of the whole assembly. We're going to slide the blow molded piece over the central core tube. We'll bring it down lower than it actually needs to be, and then epoxy the centering ring in place. Now, it's interesting to note this centering ring has 2 flat sides on it. Those flat sides we want to align with marks that I've already put in place that align with the mounting locations for the strap-on boosters. There's 4 marks on here, just so that we have plenty wherever we might need them. Okay, we've rehearsed this. Let's do it for real. We'll start by sliding that upper blow mold section down lower than where it's actually going to end up. Note that there's a bit of body tube peeking out there at the top. We'll mix up some 5-minute epoxy. I'm using a Q-tip to apply the epoxy to the exterior of that BT-60 tubing. Once the epoxy is in place, we can rotate that centering ring on. I'm aligning the laser cut mark on the flat spot with one of the black marks we made just a few moments ago. Now I'll turn the whole assembly up on a piece of waxed paper and push that centering ring down into place. We'll let this cure and then come back and complete it. We'll mix up another batch of epoxy, and then I'm going to flex the upper blow mold section out of the way. I'm going to use a toothpick to get some epoxy on the inside upper wall of that blow molded piece. I don't necessarily want to get it on the centering ring right now. I want to keep this as clean as possible. Now I'm not going to speed through this. This is not difficult, but it is the greatest opportunity to screw up your model in this entire project. So we really want to make sure that we get this particular step correct. Okay, all of our epoxy is in place. We're now going to rotate the part back up into position and line up the end of the tube with the upper surface of the centering ring. We're now going to rotate the entire assembly to line up one of the seams on that upper blow mold part with the reference line that goes through the mounting points on the lower section. I'm double and triple checking here. Okay, notice that seam comes down and it goes through that upper hole, down the reference line, all the way to that lower mounting pad. We're using our sprue cutter here to separate the detail parts for the central core from their sprues and then cleaning them up with a number 11 blade and our sanding sticks. This tiny little trim piece is the next part we'll cut from the sprue. After we clean it up with our sanding sticks, we can install it onto this Interstage cap part. It fits neatly onto any of the ribbed details on the cap, it doesn't matter which one, with the sloped side facing forward. The flat aft end is flush with the back face of the cap. A little bit of cement and we're ready to move on. The butterfly-shaped forward mounts for the strap-on boosters fit onto small raised nubs that we can find on the blow molded section. We'll use liquid cement again. Note that the narrower wings of the butterfly are at the forward end of that assembly. The rectangular mounting pads for the strap-on boosters are placed into the holes we drilled earlier with a little bit of epoxy. Note that there's a tiny indent on the pad that I've highlighted here with a black dot. We want that side of the pad at the forward end. At this point, we can add the nozzles to the static display plate for the central core. Just hit them with a sanding stick, pop the nozzles in place, and wick a little bit of liquid cement into the joints, and the component is complete. We're going to move on to our strap-on boosters now, and the first step will be to remove the ends from the blow molded components. The approach we're going to use will be the same that we used for the central core. We're going to highlight the cut lines with a fine point Sharpie and then use a razor saw to cut away the waste bits. There's a large section to remove here at the aft end and a little tiny bit to remove at the forward end. Now, back in the unboxing video, I mentioned that these were pre-production parts and that there would be a couple of minor changes in the production kits that ship to hobbyists. Now, one of the changes that we'll see is right up here at the front. There are some details up here at the forward end of the strap-on booster. They look great. The problem is they're a little tough to remove from the mold during the production process. So they're going to increase the draft angles on some of those parts. It probably won't be noticeable at all, but it is one of the changes that's going to take place. Let's go ahead and get started. We'll take our fine point Sharpie and highlight this line. Now up here at the front end, we're going to take off this round bit at the very top. That will expose a hole into which we are going to insert a detail part later. Let's grab our razor saw. I'm going to put my magnification on. That's what my magnifier looks like, in case you're interested. Again, we're going to work slowly and rotate as we work the saw. And there goes the forward bit. We'll move to the aft end. I'll bring in a sanding block to clean up this edge. And I'll also use a sanding stick to take some of the fuzz off of the edge. When most of your cut line is gone, the black line we drew on there, that's probably enough. Just a couple passes at the front end. And there, that booster's ready for assembly. Now I've already done the other three off camera. Now that we have the boosters trimmed, let's clean up the molding lines on the parts. When parts like this are blow molded, the two mold halves leave a visible line on the exterior. It won't pick up well on this camera, I'm afraid. It isn't a seam line because the plastic is a single continuous piece, but rather a parting line or a witness line. Whatever we call it, we have the opportunity to get rid of it. To do that, I'm going to use a series of sanding sticks from medium coarse grit all the way up to a super fine grit. Now, we'll want to take care not to damage the detail lines, such as these circumferential raised panel lines. To help with that, I like to use my fingernail as a guide. I just position the nail right on top of that part, that detail, and I sand right up to that point. That section looks good. We'll go down a section. Rotate the part slowly as you sand. We don't want any flat spots. I'll turn this around so I can protect the other end of the detail bit there. Okay, I'll do the rest of this off camera. Now this step isn't necessarily a required process. If you skip it, your model will look great from a couple of feet away. If you do take the time to do it though, you'll be elevating the quality of your work and adding some next level skills to your toolbox. This is the first appearance of our upper section in this video, and it too has the parting line on it. It's very finely molded. but we are going to take some time to polish it away. Now the upper section of the central core also has some parting lines. These are a little different though because they're either hidden in this detail line right up here or will be hidden under one of the strap-on boosters when they're in place. You have the option of not doing this because nobody will ever be able to see under that. Let's begin prepping the detail parts for the strap-on boosters. We'll start with the sprue that contains the forward mounts that will engage with the butterfly-shaped parts located on the central core, along with the 20 motor nozzles that we'll install on the base plates. Next up are the small fins that will slot into the sides of each booster. There's a witness line on the underside of each one of these that we'll want to gently sand away. This sprue holds the vernier motor mounts that we'll install onto the base plates, along with the vernier motor nozzles themselves. Let's start building out our boosters. We'll start with the base plate, which will just fit into the back end, the aft end of the booster. And we'll use some liquid cement to glue this into place. We'll use this sparingly, but we want to go all the way around the part. Capillary action will draw the cement down into the joint. Next, we'll add the large motor nozzles. Now these are keyed into place. There's only one way they fit. Just put it into place and rotate it until it drops into place. I'll add a little bit more adhesive on the inside joints. We'll let capillary action pull that in. Next up is the fin detail. We'll need to drill out this locating hole with a 3/64 inch drill bit. That's a little bit over 1 millimeter if you're using metric bits. The fin just drops into place. And then we can secure that with a little bit of liquid cement wicked in on the sides. Now we do want to make sure that this is absolutely perpendicular. And I'm going to apply a little bit of pressure while the cement sets up. I'm zooming in as far as I can for this next shot. There are two types of vernier motor mounts. You'll need to experiment with them a bit because they fit over little bits on the back of the base plate. There, that one fits there. I'm going to hold that in place and then wick some cement in place. little bit of pressure. I'll wick a little bit more cement on this side. Note that this attaches both to the back plate and to the side of the booster. The other one fits right here. Again, a touch of liquid cement. Hold that in place. I'm going to hold off on installing the vernier motors. I'm going to paint these separately and install them after everything is painted. They're just so fragile, I wouldn't want them to get bumped or damaged during the build process. The forward booster mounts are glued in place with a little bit of epoxy. I've mixed some up here. I'm going to use a toothpick to get it down into the hole at the forward end and get it on the walls inside. Part goes in. Now note the orientation here. I've got the smooth side, if you will, of the part in line with these details at the forward end of the booster. On the sides are the sides with detail and the hole. We have one more little tiny plastic part we need to discuss. And that's this simple rod that's included on one of the sprues. What is going to happen with that? It will be chopped up into 4 shorter pieces, and it will be used to mount the boosters onto the sides of the central core. Now the first step in that is to drill these holes out with a 3/64 bit. That's the same size bit we used to drill the fin hole on the booster. And those sections will then be inserted into there. One more thing we can do to prep for that is to find this indentation on the back of each of the boosters. Drill that out for a 3/64 hole as well. Here are the components for our interstage assembly, which will connect the lower central core with the upper stage and spacecraft fairing. This 3D printed resin interstage lattice will be sandwiched between this lower bulkhead and this upper second stage thrust assembly. We're going to prep everything now, but we're not going to put it all together until after everything is painted. Now, why are we doing that? Because it would be virtually impossible to mask and paint all of this with any hope of success. There are just too many colors and details yet to come. So the one bit of prep work we can do is to gently drill out the mounting location holes on the bulkhead and thrust structure. We don't need to drill deeply, just 2 or 3 millimeters. We'll use the same 3/64 inch drill that we used for the fin and booster mount holes. This half of our final sprue contains all of the parts for the escape tower that's mounted to the forward end of our rocket. The escape tower is a pretty cool component. It's designed to pull the spacecraft and crew free of the booster in the event of an emergency. Now, it's only been used on one occasion, the Soyuz T-10A mission in September 1983. When the Soyuz booster caught fire on the launch pad, the escape tower pulled the spacecraft clear of the unpleasantness, saving the crew. A couple of these parts have already wiggled free. Okay, so there are all of our escape tower parts. I'm going to clean them up with some sanding sticks. Okay, all of those are cleaned up. We'll set those to the side. This half of the sprue contains the cable raceway parts for the second stage of the booster. We'll install those in a moment. Now these 4 grids right here, one of which has already made a break for it, are the grid fins that would deploy in the event of a launch abort. We'll clean these up and set them to the side, as the plan is to paint them before we attach them to the spacecraft fairing. We'll do that in our next installment. Construction of our escape tower will start by gluing together the 2 longitudinal motor bits. Now, these are beautifully molded parts, so if we take care in aligning them, we can get away with a minimum amount of sanding. We'll apply some cement with a brush, allow capillary action to pull the adhesive into the joint, and then continually adjust that. Apply some gentle pressure until things set up securely, about 30 seconds. It's best to work in short sections. We'll repeat the process for the upper motor section. We'll give the cement on these about 15 minutes to settle down, and then use a progression of sanding sticks to refine the seams. After the cement sets up and completely flashes off, usually about 15 minutes, we can clean up the seams with our sanding sticks. I have just assembled the entire escape tower and neglected to hit record on the camera. So let me talk you through it. The first step was to add the tower jettison nozzles at the top of this main structure right here. That goes on a little counterintuitively. What I call the pedals actually face forward, angle forward, so that's a little counterintuitive. Once that's in place, the upper motor portion can then go on. Next up are the 4 abort nozzles. Now there's only one way each of these fit on. They have a sloped engagement in the cavity inside. So play with those without glue so you understand completely how they fit on before you commit glue to the joint. And finally, this flange attaches at the bottom very simply. It is keyed. There's only one way it fits on properly. Same with the tower jettison nozzles right here. There's only one way that fits on properly. Included with the kit instructions is a marking and alignment guide for the cable raceway parts that we're going to attach to the upper section. The version of this that ships with the final kit might look a little different than this, but it will work exactly the same. We're going to cut out these 2 marking windows right here and then trim all the way around. And then we're also going to cut out these slots down here that will fit over some details on the blow molded second stage. The placement of this template is absolutely critical. It's easy, but it's also easy to get wrong. So what we're going to do is locate this set of details on the upper blow molded section. They're just above these two longitudinal gussets, and then rotate the entire piece 180 degrees. There you'll find a similar set of gussets with no antenna details above that. This is where the template will go. We're going to position it up against this detail with these openings fitting over these longitudinal details. I'm going to put a couple of pieces of clear tape on here to lock everything in place. And then we're going to review one more time. We've got the two longitudinal details coming down, and to the right of that is the opening where we're going to apply one set of markings. Rotated about 45 degrees, 60 degrees, there's the other opening. We're going to place some pencil marks in here, in line with the lines on the template. We can put a couple more right up here to help. Rotate, do the same thing here. We can even put a couple details, a couple marks right down here. Wonderful. Let's remove the template. Both of the cable raceway parts are identical and have these incredibly helpful locator slots molded into the back of them. Those will fit over details on the blow molded component. Using the pencil marks we just installed, we're going to fit these in place one at a time. When you're satisfied with the fit and alignment, wick some thin liquid cement underneath a section of it. Apply some pressure and then move on farther up the part. Sight down the part to just make sure you're putting this on straight. I'm going to adjust this just a hair. Beautiful. We'll continue to apply cement all the way down to the base now. Again, a little bit more gentle pressure. Let's do the other side of the detail. And our first cable raceway on the upper section is in place. Let's do the other one. Same drill as before. We're using the markings we just drew into place. I'm sighting down the part just to make sure it's straight, and it is. And we're ready to move on. With that little task completed, basic construction of our Soyuz booster is essentially done. Here's an overview of the current state of play. I had to install a wider lens on the camera in order to get everything in, and there are still a couple of components off camera, like the clear flight fins. Now why, you may ask, are we not eagerly bringing all of these tasty bits together? The reason is simple. This model is going to be much, much easier to paint if we do so while everything is still in separate components. Only after everything is painted will we bring the puzzle pieces together. We'll get started on that bit of fun in our next episode. Thanks for watching.